Can you hear me?
Yes, I can. Can you hear me?
All right. Yeah, I can hear you. How are you?
I am doing okay. Thank you.
Yeah.
And you?
Good, thank you. All right, so we are going to have algorithms data structure interview session. It's going to last for 45 minutes. So before we start, could you please tell me about your experience and about your goals?
Yeah. I am a recent graduate. I just started working a few months ago. Um, and I am looking to switch jobs. So I'm gonna start interviewing by the end of this year. And yeah, I currently, just a few months on the job. I am a front end software engineer as well. So just looking to get some practice.
Okay, that sounds good. Do you have any plans in terms of like what companies you're applying for?
Yeah, fan companies and other um, top companies, I guess.
Mm-hmm. And what position? Okay, okay, you said
New,
under
yeah, new
so
grad.
it's new grad. Okay, so it's probably going to be something like entry level position, right?
Yes, entry
Mm-hmm.
level. Yeah.
Sounds good. Okay, in this case, I think I'm gonna just ask you a regular question that I usually ask on a real interview.
Okay.
Uh, yeah. So let's try to solve this one.
Okay. Given an integer array nums and two integers left and right. Okay. Return the number of contiguous non-empty subarrays such that the value of the max is in the range left to right. You have a left and right, and we're saying return. I'm just going to highlight. So return number of contiguous non-empty subarray, right? Then the max array element in that subarray is in range left to right. Right. I think those are the two main points. So the left and right, is that inclusive of the right
Correct.
and left? Okay. And in this example, right, the max is in the range 2, 3. Okay. Do we have negative numbers in our array?
Yeah, there can be negatives.
Okay. And what's like the maximum number I can be looking at?
I think we can like basically think you about some solutions before we jump into. Basically, we can assume that there's nothing special about these numbers.
Okay. Okay.
Yeah.
Right. Okay. So I'm thinking number of subarrays in that range. Okay. So the brute force solution would be to say get all the subarrays, right? And then check, get all the subarrays, and then check which ones are in that range from left to right. So, for
Mm-hmm.
example, you would say for, can I just quickly just demonstrate what the brute force looks like
Mm-hmm.
in pseudocode. So you say for num in nums and for, well, you say something like this, and then you start your other loop from j in range I to the end, right?
Mm-hmm.
And then for all the subarrays from I to j, you'd want to test um, if the subarray is in that range,
Mm-hmm.
right? So that would give you a time complexity of n cubed, um, where n is the size of the array,
Mm-hmm.
and it would give you a space complexity of constant space,
Yeah, that's correct.
right?
Mm-hmm.
So to improve upon this, um, okay, I'm just going to make one quick comment here. So I'm just going to check that. Um, check that the subarray is in range left to right. Right. So that's ON time. Okay. Um, a better approach. Let's see. So for number of subarrays, we can, let's say we have 1, 2, and 3. Is it okay to include duplicate
Yeah, there can be
subarrays?
duplicates.
Okay. Let's say we have 1, 2, and, well, wait. Let's say we have 1, right? There's just one subarray. If you have 1 and 2, that's just one.
Yeah,
Right. That's just 1, 2, and 1, 2. All right. If you have 1, 2, 3, we're taking all of the previous subarrays, and then we're adding 1, 2. We're adding 2, 3, and 1, 2, 3.
correct.
Right. So the
Yeah,
subarrays,
also,
they always,
I think also we missed just 3.
yeah. So, hmm. So that means there's one subarray here, right? There
Yeah,
are
yeah. So are we
3
talking about?
subarrays.
Yeah, sorry. Are we talking about when left and right is 2 and 3?
No, I'm just trying to find a way to quickly calculate the number of subarrays between a range.
I see. And the range
So,
is.
well, between, let me not say range. When there are n, if you have n numbers in your subarray, right? 3 numbers in your subarray, how many subarrays if you have 3 numbers in your array, how many subarrays do you have? That's what I'm trying to quickly find. And then I want to use that to like reduce the complexity. Does that make sense?
Uh, this yeah, this is one way of doing that. Yeah, but maybe we can also I guess here we are aiming for maybe something like linear solution here.
Okay.
Maybe we can also work on this solution that you proposed here and see if we can like somehow optimize this one instead.
Okay. Yeah. So, okay. So for this one, I was going to say that it looks like um, you can reduce this complexity of the check and you can reduce it to constant because the number of sub-arrays, if you just if you're taking one number, well, wait. If I was trying to demonstrate that the number of sub-arrays, right? If you have let's just say some random numbers, 7, 8, 9, 10, then the number of sub-arrays is really um, the sum of numbers. So in here you have 4 times 4 plus 1 divided by 2.
Mm-hmm.
Um, so in here, right, 20 divided by 2, that's just 10, right? And if, for our case, if n is 3, that would be 3 times 4 divided by 2, which will give you 6. So that's 6 sub-arrays.
Yeah.
So, um, let's see. Hmm. If we can, okay, let me go back to this question. If I know if I know the number of sub-arrays given some array size,
Mm-hmm.
I think I can then do a two-pointer approach, right? So I would say given 2, 1, 4, 3, if I said keep extending the array while so wait, I, I was going to say, okay, find a sub array such that the max number is right is in range left to right.
Mm-hmm.
So if you extend this, one is not well the max number, right. One can be included in the sub array as long as the max number is in range 2 to 3. Right. So if I then extend this again, then now the max in that subarray is 4, right? So we take this subarray and then we use the formula to find the number of subarrays, right? Given, you know, 2 items in the subarray, right? So if we add, let's say, 2, 3, 2, for example, let me add one more, yeah. So initially we'd get 210, right? Max is in that range. Then once we get here, we reset the pointer, and this is outside the range, so just move forward again. And then this one is inside the range, so you calculate the sum of numbers for four numbers, right? And we add them up.
Yeah, but how do you
Let me think about
yes.
let me think about edge cases there. Right. For this one, right, if you have 210 and you calculate the number of subarrays, we actually want to exclude arrays like 10 or 0 or 1, right? So 210, sum of numbers, that would give you 3 times 2 divided by 2. Sorry, no, 3 times 4. Yeah, 3 times n plus 1. Yeah, that gives you 6 subarrays, right? However, interestingly, we have to actually exclude
Correct.
subarrays like 1 0, 1 0, right? So let me think about that for a second. Right. Wait. We want to exclude subarrays that exclude subarrays that are in the range negative infinity to left minus 1. All right. So because right, right. If we find subarrays that are in the range I'm thinking of other edge cases now. It's a little tricky. So okay, right now I'm just saying find subarrays where their max is okay. Let me write that down. Use the sliding window. to find subarray in the range. Okay, so what I was doing here, right? We included 1, we included 0, even though they are less than left, right? Because numbers that are less than left can be joined to numbers in the range. Okay, so use sliding window to find subarray in the range negative infinity to right, right? Because we do not want a number like 4 in our subarray. It's we don't want that. But we want all numbers from want all numbers in the range and lower than the range, right? And then we want to subtract that. You say, I'm just gonna copy this, right? So once you get this one, we want to exclude, like we said, subarrays like this.
Mm-hmm.
So you can just say, you can just say subarray, all of the subarrays from negative infinity to right minus subarrays from negative infinity to left minus 1. And that would give you the subarrays from left to right. Yeah, that's my approach.
Mm-hmm. Okay, so
Does that
basically,
make sense?
yeah, I think that what you're, yeah, can you please repeat one more time how you're going to calculate this number of subarrays that are in the range? Oh, I see. You're going to iterate through this array with these parameters, basically minus infinity and left minus 1, right? Mm-hmm. I see
Yeah,
what you mean. Okay. And got it. Yeah, I think that sounds good to me. Yeah, let's
yeah,
do this.
and the complexity would be linear time, and the space complexity should be constant.
Mm-hmm.
Is constant. Yeah.
Yeah.
Okay. Is that okay?
Yeah, I think it looks very good here. Let's try to implement it.
Okay. So let's see. Define get um, number sub array in range. So you have your left, your right, and this returns an integer. Okay. So we're using 2 pointers. You can say left pointer equals right pointer equals 0. And then set size. Oh, and the number, of course.
Yep.
And nouns, list of integers. And size is equal to the length of numbers. Okay. Let's see. Do you want me to talk through my code as I'm coding?
It's well, you can do this. Yeah. So I think it's can do this. It's up to you.
We can. I should. Okay. Okay. Let's see. Um, you have 2143. You'd want to extend the right pointer. So say while right pointer is less than size and um so okay, let's see. We want to include numbers in the range left to right. So and left, let me look at that again. So you have your right pointer. Uh, so but we also want to make sure that the maximum in that subarray is in that range.
Hmm.
Hmm. If I just used this one, hmm, it would include as long as the number is okay. So this would really be just an helper method
Yeah.
to get for these two things,
Right.
right? So as long as that number is within left and right, you add it. Okay. So right pointer starts from 0 and then right, you get 0, non-sub 0, move 1, you try it, move the pointer, you try it. So once you move the pointer and it's outside of the range left to right, that's when we stop. So now you have the number of subarrays as left, let me just say array sub array size would be equal to right minus left. Right, since the right would stop at a number that is outside the range, and the left would be the first one. So in this case, you'd have like 2 minus 0 to give you these two numbers. Okay, so sub array count would be equal to sub array size times sub array size plus 1 divided by 2. Right. And I'm just going to have a count plus equals subarray count. And then once you're done, you can left pointer equals right pointer. And yeah, we can just say, hmm, you know what? Yeah, we can say if nonce sub left pointer um, is greater than right. Okay. While left pointer is less than size and that, if non-sub left pointer is greater than right, we want to skip that number. Sorry, greater than, oh no, okay, yeah, that looks good. I wanted to say greater than or equals, but no. So you skip that number, and then once you get to where you want to start, right, then you make sure the 2 pointers are on the same number, and then um, yeah, you just keep extending the window until you have a number that doesn't match.
Mm-hmm.
And then once you're done with that, you get the array size and all of that. Okay. Oops, did I remove something? Okay, no. And then once you're done, you return the count. And then you can say um, get uh, array count. You have left, right, integer, nonce, a list of integers, and we're returning just this. Right. Okay. And now, like we said, you just want to say get number sub arrays in range negative infinity to left minus one. Um, and negative infinity to right. So let's call this
Mm-hmm.
count loss less equal, right? No, that I don't know. So if there was, say, if it was empty, it's just wait. I didn't even pass my numbers. If it was empty, then the solver just return zero. Um, right, and we said we're fine with duplicate. Um, Let me look at this one more time.
Mm-hmm.
Hmm. I think this implicitly makes sure that the maximum is in the range left to right. That's the one thing I'm just trying to be certain about.
Mm-hmm.
Yeah, I mean, as long as you only include numbers. So, okay, negative infinity, left minus 1, right, negative infinity, right. Yeah,
Mm-hmm.
okay.
Okay.
How does this look? What do you
Yeah.
think?
Yeah. I think looks good to me. I think. Yeah. I think it's pretty good. I think that so generally, yeah, this is the question I generally ask. I think you did pretty well, and if you want, we have
Hmm?
time for one more question, and you
Yeah,
can like choose a topic that you would like to practice, maybe.
yeah, let's do
There
one
are,
more.
yeah. So there are,
Um,
yeah.
there's really not a topic in mind. I don't mind.
What company are you actually applying for? Like, maybe what's your like dream company?
Um,
Like Google, for example, or
yeah, Google, um, Facebook, Apple,
okay.
yeah.
Okay, let me ask you something that you may face at Google. Okay.
Okay.
Yeah. Okay. Let me ask you this problem. And let me also send you the picture address to the picture because I cannot copy paste the picture as well.
Okay. Okay. Given an n by n integers matrix, return the length of the longest increasing path in matrix. From each cell, you can either move in four directions. You may not move diagonally or move outside the boundary. Wrap around. Oh, right. Okay. And then given 994, 668, and 211, the longest is 1269. Huh. Okay. Hmm. Okay. The brute force. solution. Wait, how long is this? How how big is this matrix? What's the max
We can,
n and max n?
yeah, we can assume that, I guess like you can maybe propose a solution and we can like go, take it from there.
Okay.
Yeah.
Okay. Um, okay. So the brute force solution, let's see, you'd want to find every single path,
Mm-hmm.
um, and then, just see which one is the longest. So the complexity for finding every single path, let's see. So, okay, in a matrix, you can move right or you can move down. Usually, you would not want to. Hmm, I think usually you would not want to move. If you move left, okay, yeah, you can move. You can move in four directions. Um, I want to say the complexity would be. Let me write that down. The time complexity for brute force, right? It would be 4 to the um, since it's basically just a tree and the
Mm-hmm.
four directions are the four what's it called? The four children of the tree, and the tree is as long as um, the number of items, so n times n.
Okay.
Although more realistically, you're not always going to be like moving four directions because you're coming from somewhere. So it's I don't know if it matters in big O, but I think it's more closer to 3 to the n times m. But anyways,
Yeah, it's
the
basically,
space,
yeah. Yeah, go ahead.
yeah, the space complexity, um, usually, well, I would use recursion if I was going to solve it this way. So the space complexity would just be the stack, recursive stack, however long it is, which would be n times m. And yeah, we don't need to keep track of we don't need to store the path. We can just um, take it along in the recursive um,
Mm-hmm.
stacks.
Yeah.
So, right, a better approach, let's see, longest increasing, longest increasing. And thinking about DP,
Okay.
dynamic programming, um, wait, before I jump to dynamic programming, we can prune brute force solution by saying if you only want to get something that's increasing,
Mm-hmm.
well, okay, that's more like in the real world. If it's big or the worst case, everything is going to be increasing. So, or most paths are going to be increasing, and it still comes down to the same time complexity.
Mm-hmm.
Um, okay, and for DP, let me see, longest increasing. So it's basically just like longest increasing is the same as longest decreasing. So so in the diagram, you can really also go from 9 to 6 to 2 to 1. Then have to go from 1 to 2 to 6 to 9. Um, hmm, let's see. If you had, let me simplify this problem. If we had just one, if we had just one array, let's say, um, does the number, is negative numbers, is that included?
It's possible, yeah.
Yeah, okay.
Well,
Yeah,
if you want,
so,
you can assume that we will not have negative numbers. Like, why,
okay.
why, why are you asking?
Um, I was thinking, it adds complexity because negative numbers can like cut down the path that's increasing. So you have 1 to 3, negative 1, 4, 5, for example.
Mm-hmm.
And if you had like some, I guess it's strictly increasing, right? If you have 3, 3, 4, 5,
Right, it has to be strictly increasing, yes.
right, right. Yeah. So if it was just one array, it's it's a whole lot simpler. Um, to use BP. So if we said dp of ij let's see, is the longest increasing um, ending at ij.
Mm-hmm.
So we only care about left and up because down, those are down is unexplored. What is it called? Unexplored nodes. And right is also unexplored nodes, like the future nodes. But left is where you're coming from, and up can also be where you're coming from, right? So that means we can say something like dp of ij is equal to the max of dp of I. So, okay. Up is I minus 1 j, and left is I j minus 1. And then you add that
So can I ask you
max.
why do we only consider left and up?
So left and up only because I'm starting from the top. I'm going to start my loop from the top left, right from
Yeah,
0, 0.
but how about the if you have a path, something like that, 6, 5, 4, 3.
You mean if they're
Yeah, if
like
you had
other
like
numbers,
correct, yes.
right?
Mhm.
Yes. So this would, you would say, so for example, the DP of this position, right? Well, are you saying, well, there's not always a left, if that's what you're asking?
Yeah, so in this case, you will have to go.
Um,
You'll have to go from the bottom to the top, right? Uh, so it's
wait.
actually I think what you're doing is oh wait, I think you're sorry. I think let me give you this. Oh wait, yeah, I think what I was going to say is that if you have, for example, like this, actually, I think this will contradict your approach, right? Because you have to go down now instead of going up.
Hmm. Well, we can just do two. Wait, let me think about that. I think we can solve that by doing two different DPs. One where you start from the top left, and another where you start from the bottom right.
I don't think it is also so. Well, it. I don't believe it will solve the problem because we might have also a situation that we have sort of like a zigzag. You know, we have like zigzag, and this would require us to like apply your solution from like your first solution several times, then again your another solution like that goes from different direction, and again first one, then again second one if you have like some kind of zigzagging situation, right? Does it make sense or?
So by zigzag, you mean, let's say we have, excuse me, let's say we have,
Yeah, let me give you an example. We have, for example,
okay,
9 and 7 6, not really a zigzag, 5 4 3 2 1 0, right? So here you will.
huh. Let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is your longest. I see. Huh. Interesting.
So you know what I suggest? I suggest to leave this as your as a homework because it's like a interesting topic that probably you want to explore a little bit more. It's like a graph theory
Uh-huh.
plus DP. There are lots of like problems like that you may face at Google that
Mm.
require this some type of graph traversal and some type of memoization. And well, I can tell you solution either now or you can just probably explore it a
Is
little
it,
bit.
is it, I assume it's a lead code question, right?
Yeah, it's a lead code, yes, and I can like, give you the
Okay.
link. Yeah, here's the link on the line 73. Yeah, I can see
Okay.
more, but
I'll go explore.
definitely your time complexity and space complexity is it's not like it's like closer to right. Yes, it's nice that you be able to understand its complex approach. And another positive thing is that you were able to see that's a DP, and also the pruning that you're suggesting to use is also useful, but we still have to use DP even if you use pruning.
Yeah.
Yeah. So yeah, I think that you were on the right direction. That's for sure. You just need probably more time to think about this problem. And also regarding the first problem, yeah, I think I definitely have a very positive feedback about your first problem. Your technical skill was very good. Your code, the way you
Thank
code
you.
is, yeah, it was very good. It's very easy to understand. Your thought process was very clear to me. Yeah, and you started with a brute force approach. It was also very nice. In terms of problem solving, yeah, you were able to figure this out without my help.
Yeah.
Yeah, it was very nice. It was the best possible approach in terms of time and space
Thank you.
complexity. Yeah. Yeah, and the communication was very nice. You walked me through this approach. Maybe what you could improve in terms of communication, though, is kind of as you probably noticed, we kind of it's just slight maybe improvement that you could before start coding, you could maybe kind of walk through this approach a little bit more to to kind of visualize it a little bit better for yourself. Uh, so
Mm.
you did not get stuck at all when you started coding. Maybe this is just one slight improvement you could have done because because as you can see, if you just see at the number of lines of code that we needed is only, what is this, 17 lines of code, right? 18. And
Yeah.
for 18 lines of code we spent about, it was about 17 minutes or so, which is maybe you could have spent less, right? You can literally
Mm-hmm.
can code it for 2 minutes. You just need to but for this you need to kind of get confident about your approach and know your approach pretty well, especially with this when you're dealing with these
Yeah.
two pointers. When you're dealing with 2 pointers, it's nice. It's very nice when you do some type of a visualization, probably, so you understand it better.
Yeah.
But nevertheless, I think you were able to solve it, yes, within the appropriate time. So I think, yeah, it definitely would be a positive feedback for me. Yeah. Yeah. Do you have any questions?
No, I don't think so. Yeah, I like the questions,
Mm.
and I would look into this. And
Yeah, I tried to look into
yeah.
this. Yeah, there's also some question that I had sometime at Google. It was something I also had to. There's a given a ticket numbers, sorry, not ticket numbers, given a tickets, air tickets, right? That each ticket has information about destination, source airport, destination airport, and also time when it flies.
Yeah.
And those problem, it's also graph problems, and it's also frequently asked at Google and on the Facebook as well. And also you need to apply some
Mm.
DP there, just like for this one. So yeah, you want to look into this one
Mm.
after you're looking at this one.
Okay.
Okay, then yeah, that's pretty much it for me.
All right. Thank you. Thank you.
Yeah,
It was
yeah, thank
very
you.
helpful.
Yeah, have a good day. Yeah, good luck.
You too. Bye.